Today is a continuation of what we did with 4.6 part 1, using the fundamental theorem of algebra to find zeros. And this is actually the third time I've recorded this video, which is not usual for me, because what I'm finding is that the examples that I have in the notes packet for today are not similar enough to your assignment for my liking. So we are going to do different examples than what are listed here. It's the same process. I'm just choosing some better problems that are more similar to what you're going to be seeing in your assignment. So we are going to start our first example with f of x equals x to the fourth plus 3x to the third plus 6x squared plus 12x plus 8. Yesterday, we stuck with only functions that had a degree of 3. Today, we're going to look at functions that have a degree of 4. And once you know how to do this with a degree of 4, you could do this with a degree of 5 or 6 or anything larger. Anytime you're larger than, really anytime, you should always check for greatest common factor or any other factoring that you could do. In this case, there's no factoring that we can do. So we're going to start with what we learned yesterday. The first thing that we learned yesterday was that the degree is going to give us the possible number of solutions. So this is a fourth degree. That means there are 4 possible solutions. The positive solutions are going to come from the number of sign changes. So this first term is positive. The second term is still positive, still positive, still positive, still positive. There's no sign changes here. Our negatives, the negative and positive solutions have to add up to 4. So that means we have the possibility of 4 negative solutions or less by 2. Descartes' rule of signs says or less by 2. So 4 or 2 or 0. Now here's the thing. There's 0 positive solutions. Descartes' rule of signs tells us there are 0 positive solutions. So don't test the positives. Definitely test the negatives. Even though there's the potential for 0, there's got to be something. So it's got to be either the 4 or the 2. We're going to test the negatives. The suspects, the suspects for the solutions come from our constant term. So ways to multiply to get 8. We've got 1 times 8 and we've got 2 times 4. So these are our suspects. And I'm going to test -1, -2, -4, and -8. Hopefully I won't have to test all of them, but these are the numbers that we're going to have to test to find a solution. We test using synthetic division, and it's going to be very important, and you'll see this, I think, in one of your assignment problems. We don't have an example like it, but sometimes the x cubed term is missing, or the x squared term is missing. So before you do synthetic division, please make sure that you have all of your terms. Make sure you've got x to the fourth, x to the third, x squared, x, and a number. If you don't, make sure you put a 0x to the third or whatever in its place, in the missing term's place. So we've got 1x to the fourth, 3x to the third, 6x squared, 12x, and 8. And I'm going to test -1 first. -1 times 1 is -1. Add them. -1 times 2 is -2. Add them. -1 times 4 is -4. Add them. Hey, this looks good. -1 times 8 is -8. Add them. And yay, we got 0. This means -1 is a solution. So in Big Ideas Math, I think on these you have to click to select your answers. But on your paper, if you're like keeping track of your solutions, you can go ahead and write down that -1 is one of your solutions. All right. This means we've got 0 equals x plus 1. The x plus 1 comes from this solution. If that's a solution, we've got x plus 1 in the factored form. The stuff underneath the synthetic division in front of the 0 is going to give you the next part of your factored form. Now yesterday it was always x squared, but we didn't start with x cubed today. Today we started with x to the 4th. We started with x to the 4th and we just pulled one of those x's out. So now this term is an x cubed term. So x cubed plus 2x squared plus 4x plus 8. Okay, now here's the deal. Sometimes these 4 terms we will be able to factor by grouping. Sometimes we won't. So you should always check to see if we can factor by grouping. The first 2 terms would have x squared in common. That would be x plus 2. The next 2 would have 4 in common. That's good. Factor by grouping worked. We've got x squared plus 4 times x plus 2. We have the 0 equals x plus 1 from before. So our solutions are -1, we've got that one already, -2. Can we factor x squared plus 4 more? It's x squared plus, so no, we really can't. We can put x squared plus 4 equal to 0. I'm going to zoom in on that a little bit. Subtract 4 on both sides. Take the square root. Do you remember how to do the square root of negative numbers? Because you need to remember how to do the square root of negative numbers. The square root of -4 is the same as the square root of -1 times the square root of 4. The square root of 4 is 2. The square root of -1 is the imaginary number I. Now, when we put a square root in the process of solving, we also have to put a plus minus in front of that solution. This means one of our solutions is 2i, the other solution is -2i. All right, now the fundamental theorem of algebra and Descartes' rule of signs tells us how many real number solutions there could be. We ended up with 2 real number negative solutions. There are 0 positive solutions. There are 0 positive real number solutions. This is why it's or less by 2, because sometimes 2 of the solutions are taken up by imaginary numbers. So that's why that Descartes' rule of signs with the or less by 2, that's why that's important, because sometimes 2 of your solutions are taken up by imaginary numbers. All right, let's try our next one. Okay, take a moment. I would go to the next page of your notes and write our new example 2. So pause the video, get this written down. All right, on your own, I want you to determine how many solutions and how many positives and how many negatives. So pause the video and do that part on your own. Okay, this is a 4th degree polynomial, so there's the potential for 4 solutions. For the positive solutions, we've got a positive term, changes to negative, stays negative, changes to positive. So there's 2 sign changes. So there's 2 or 0 positive solutions. That means there's 2 or 0 negative solutions. This is a toss-up. You can test whichever numbers you want. The suspects come from the number 30. So ways to multiply to get 30. We've got 1 times 30. We've got 2 times 15. We've got 3 times 10. And we've got 5 times 6. I'm going to test positives because when I am given the choice, when it doesn't matter which one we choose, I'm going to use positive numbers because I feel like they're just easier. Again, check to make sure you're not missing a term. On your assignment, on one of the problems, you'll be missing your x cubed term, so you'll need to put a 0 for the x cubed term. In our case, we are not missing any terms, so 1, 5, -7, -29, and 30. This one has bigger numbers, which is a little concerning, but I think we can handle it. I'm going to test positive 1. 1 times 1 is 1. Add them. 1 times 6 is 6. Add them. -1. Add them. -30. Add them. Yay! We got our 0 the first try. So if you're keeping track of your solutions, x equals 1 is one of your solutions. We can now start the factored form. X minus 1, and this stuff is going to give us the next part of that factored form. We've got x cubed. We started with x to the 4th. We just took one of the x's out, so now we're at x cubed. You decrease that exponent by 1 when you write the second parentheses. X cubed plus 6x squared minus 1x minus 30. Now, just like we did last time, we're going to start by trying to factor by grouping. When I try to factor by grouping, these two have x squared in common, x plus 6. These two have -1 in common, x plus 30. Shoot, those two parentheses are not the same. That means factor by grouping didn't work. We can't factor by grouping on this one. So what do you do if you can't do factor by grouping? If only we knew how to factor when factor by grouping doesn't work. Oh, wait, we do now. It's called using the fundamental theorem of algebra, Descartes' rule of signs, and testing with synthetic division. So now we are going to look at this thing and say this piece, just this piece, we're kind of putting the rest of this on hold and we're just looking at this piece. This piece, there are 3 possible solutions. We've got a positive term, change to negative, stay negative. There's 1 sign change. So I'm going to test the positives. And our suspects still come from the number 30. So I'm still going to use the same list of 30. I'm going to try positive 1. Oh, we already did positive 1. Positive 1 is already a solution. So now I'm going to try positive 2. And this time we are testing with this piece. So 1, 6, -1, -30. I've already tested positive 1. That is a solution. We need to now go with 2. 2 times 1 is 2. Add them. 16. Add them. 30. I am getting really lucky with these. So x equals 2 is a solution. Let's update what I have boxed right there. We've got the x minus 1 from before. Now this 2 tells us that we have x minus 2, and then this is going to give us the rest of this. This time we had x cubed, we pulled an x out, so now this is x squared plus 8x plus 15. And now we need to factor. So we need 2 numbers that multiply to give us 15 and add up to 8. That would be 3 and 5. So our factored form is x minus 1, x minus 2, x plus 3, x plus 5. And that means that our solutions are positive 1, positive 2, we found those already, -3, and -5. These are all of your solutions. On your assignment, I believe it's just like a grid of numbers, and you have to click all of the numbers that are the solutions to your polynomial.